Hello everybody, in this video we're going to look at some extra examples on specific heat capacity. If you haven't watched the video on specific heat capacity yet, I suggest you watch that first. You can click on the link at the top of the video or the link down in the description below. Now if you are ready, let's get to it. Your mom bought you a cup of cold milk that is at 10 degrees Celsius. Your dad bought you a cup of hot tea that is at 70 degrees Celsius. The 0.2 kg cold milk, which has specific heat capacity of 3,700 joules per kilogram per Kelvin, is too cold for you, while the 0.3 kg hot tea with specific heat capacity of 4,000 joules per kg per Kelvin is too hot for you. You decide to mix them to get milk tea. What is the temperature of the milk tea? Now, we can think of it this way. When you mix the two drinks together, the heat from the hot drink will go into the cold drink, and eventually both of them will come to the same temperature. So, in equation form, we can write it as the Q, which is the heat, that comes out from the hot tea, will be the same as the Q, which again is the heat that goes in to the cold milk. And we also know that from this chapter, Q is equals to mc theta. So we know that the mc theta of the T must be the same as the mc theta of the milk. And from the question, we can get this information. The tea weighs 0.3 kgs with the specific heat capacity of 4,000 joules per kg per Kelvin. So 0.3 multiplied by 4,000. Now I don't know what the change in temperature is because I don't know what the final temperature is. But I know this. The tea starts from 70 degrees Celsius and eventually goes to a final temperature. So I can say that my temperature difference is 70 minus whatever final temperature it gets to, which I'll leave it as T. Now, I don't change the temperature to kelvins because remember, if I change it to kelvins, the temperature difference will still be the same. So it's really up to you. For the milk, the mass is 0.2 kgs with a specific heat capacity of 3,700. Again, I don't know the temperature difference, but at least I know the milk starts from 10 degrees Celsius and eventually goes up to the final temperature, T. So my temperature difference would be T minus 10 degrees Celsius. So now, all I have to do is expand these equations. So the left side will be 1200 multiplied by 70 minus T. And the right side will become 740 times T minus 10. So I expand the equations to get 84,000 minus 1200 T is equals to 740 T minus 7,400. All I have to do is move some things around and I'll get 84,000 plus 7,400 is equals to 740 T plus 1,200 T. And this will then become 91,400 is equals to 1,940 T. So to get T, all I have to do is divide 91,400 with 1,940. So T is equals to 47.11 degrees Celsius. That's my final temperature of my milk tea. The second example. Your balls are hot. Here, of course, I'm talking about your freshly cooked boba that weighs 0.05 kg. So you throw them into the 0.5 kg milk tea that you've just prepared. The temperature of the boba drops from 80 degrees Celsius to 50 degrees Celsius. The specific heat capacity of the boba and the milk tea are 3200 and 3800 respectively. What is the temperature increase in the milk tea? Again, it's the same concept, whereby when you put the two things together, the heat from the hot stuff will go into the cold stuff. So in this case, the heat, which is a Q, that comes out from the boba will be the same heat, which is also Q, that goes into the milk tea. So now all I have to do is put the MC theta of the boba to be equals to the MC theta of the milk tea. So the mass of the boba is 0.05 kilograms. The specific heat capacity of the boba, that's 3200, and the theta temperature change is from 80 to 50. So 0.05. So 0.05 multiplied by 3200 multiplied by 80 minus 50. That is equals to the mass of the milk tea, which is 0.5, multiplied by the specific heat capacity of the milk tea, 3800, and multiplied by the temperature change, which we're trying to find. 0.5 multiplied by 3800 multiplied by theta. Remember that we don't have to find the final temperature of the milk tea, because the question is asking for a temperature increase, meaning the change in temperature, which is theta. So now all I have to do is calculate the equation. 0.05 times 3200 times 30 is 4800. That is equals to 0.5 times 3800, which is 1900 theta. So the temperature increase of the milk tea due to the hot boba is 4800 divided by 1900, which is 2.53 degrees Celsius, or degrees Kelvin, whichever you like, because again, the difference in Celsius and Kelvins are the same. Just to prove that the difference in Celsius and the difference in Kelvins are the same, I've prepared a small little example for you. So the initial temperature of something is 35 degrees Celsius, while the final temperature is 72 degrees Celsius. Now, in Kelvins, both of these are equals to 35 plus 273, that's 308 Kelvins, and 72 plus 273, that is 345. Now, the difference in Celsius is 72 minus 35, which will give me 37 degrees, and the difference in Kelvins is 345 minus 308, which will also give me 37 degrees. So there you have it, the proof that the change in temperature in terms of Celsius and the change in temperature in terms of Kelvins are the same. That's all the examples we have on specific heat capacity. If you enjoyed the video or learned something new, remember to like and subscribe to my channel and share it with your friends who need them. I'm WeiEn Physics, and I'll see you in the next video. Never stop learning.